For today, we're going to focus on trig functions of standard position angles. Right now, go ahead and check your answers on the warm-up to start. Today, we're going to be talking about angles in standard position. So we're going to highlight that red here, the word. We talked about that last time, where it starts on an initial side. So if you look to the circle at the right, I'm highlighting that red as well. Okay. Now, these angles in standard position, they always have a terminal side. That terminal side is represented by this blue line over here. Remember that positive angles rotate counterclockwise, as this one's showing, and negative angles rotate clockwise, which is starting down from that positive x-axis. So if we're always working on this axis here, we can just find this equation of a circle as x squared plus y squared equals r squared, where r represents the radius of the circle. It also represents the hypotenuse of the triangle. As a result, we're going to have 6 trigonometric functions. The first one is going to be sine of theta equals y over r. Cosine of theta is the second one, x over r. And tangent of theta is y over x. And we get those values just by thinking about, if we look at the circle on the right, we have a triangle being formed. We always want to form the triangle with the closest straight line straight down to the x-axis, never over to the y-axis, to the x-axis only. And what happens if we think about the angle that's formed inside the triangle, we're going to call that theta prime. That's going to be our reference angle, and that's what we're going to be using to evaluate these trig functions today. All right, and we think about, well, if we do sine, we're going to be doing opposite over hypotenuse. That's where the y over r comes from. If we do cosine, we do adjacent, the side next to the angle, x over the hypotenuse, which is r. And then if we do tangent, we do opposite over adjacent, which is where we get the y over x. So we'll see that the sine always corresponds to y over the radius, cosine is always x over the radius, and tangent is always going to be the y over x. Now these other trig functions over here are called reciprocal trig functions. There's cosecant, which is the reciprocal of sine. And if you remember reciprocal, that's just going to be r over y. Cosine is the reciprocal of secant. That's going to be r over x. And then the last one, tangent, the reciprocal is called cotangent. That's going to be x over y. Those are the 3 reciprocal trig functions. So whenever you see the 6 trigonometric functions, that's what I'm going to be referring to. 6 trigonometric functions. There's cosecant, secant, cotangent, tangent, cosine, and sine. Another important note, it says x and y can be positive or negative, but r must always be positive. All right, and that's just because r is going to be considered a magnitude, which is why it's considered a positive value. But x and y can be positive or negative, and that depends on which quadrants they're in. And we'll talk about that part a little later in the video. I already mentioned r is going to be the radius of the circle, and it's also going to be the hypotenuse of the right triangle. When we're talking about the center of the circle, we always want to think about the origin, 0, 0. And the radius is always going to be this value r right here. All right, now we'll take a look at an example. So we say, let negative 4, 3 be a point on the terminal side of an angle in standard position. So again, in standard position, that means we're going to be starting over here on the positive x-axis, and we're going to be rotating. We're going to go to negative 4, 1, 2, 3, 4. There's our negative 4. And positive 3, 1, 2, 3. So our negative 4, 3 is going to be somewhere over here. So if I were to draw a line from the origin, this is what our angle theta is going to look like. From here, now we're going to evaluate the 6 trigonometric functions. That means we want to evaluate sine of theta, cosine of theta, tangent of theta, all 6 of them. In order to evaluate those 6 trig functions, we're going to draw a line straight down, and that's going to form our right triangle. And we know that the x value is positive 3, the y value is negative 4. But we still need to find out what the hypotenuse is. So this is where that equation comes in, that's like the Pythagorean theorem, x squared plus y squared equals r squared, where x is going to be 3 squared, y is going to be negative 4 squared, and we're solving for r. 3 squared happens to be 9. Negative 4 squared, negative 4 times the negative 4 is a positive 16. So we end up getting 25 equals r squared, square root both sides, and 5 equals r. And we said r is always a positive value, so we don't need to worry about plus or minus r in this case. So that's how we find the y value. Now, it doesn't matter what the angle is inside the triangle. We're just going to call it theta prime. We'll talk about that in a minute. But now we're going to evaluate this triangle for sine, cosine, and tangent. Sine is opposite. We'll make the y value red. So that way we say sine is 3, and then over, and we'll make the hypotenuse green, 3/5. And then that means cosine is going to be negative 4 over 5. And tangent, the last one, y over x. So it's going to be 3 over negative 4. Then to find the reciprocal trig functions, we simply flip each one over. So for cosecant, we're going to have 5/3. Secant, we're going to have 5 over negative 4. And cotangent, we're going to get negative 4/3. And that's how we would use one ordered pair to evaluate 6 trigonometric functions. We have to build the triangle, draw the angle in center position, find the hypotenuse of that triangle, and then we can write down our 6 trig values. Let's go ahead and move on to the next page. All right, so the unit circle is when we deal with this equation x squared plus y squared equals 1. It's called the unit circle because the radius happens to be 1 unit. So r equals 1 in this case. And we see that over here on the drawing as well, that r equals 1. So if we were to create a full circle, that's what we'd end up with. Now what happens in this situation, wherever we end up on the circle, the x and y values, like let's say right now we draw a line straight down. We'll draw our x value on the x-axis. We'll draw our y value on the y-axis. And what happens if we're dealing with this angle theta that's hiding inside there, if we did sine, we're going to do y over 1. And what happens is the 1, well, it'd be technically y over r, which is the same as y over 1. And anything divided by 1 is just going to be that value. So the sine is really just the y value. This is why we love the unit circle. Because instead of doing y over r, now we're just saying y. Sine represents the y values on the circle. Similarly, we can do the same thing with cosine. Normally we would say x over r like we did in the front of the paper, but since the radius is 1, we're going to do x over 1, so cosine equals x. In most situations, we'll be able to draw a triangle back to the x-axis and then use the y over r or the x over r for sine and cosine, and y over x for tangent. The only exception for that is going to be what's called quadrantal angles. And that's where you're going to see the terminal side lies on either the y or the x-axis. We're going to see these quadrantal angles when you have values of 90 degrees or multiples of 90 degrees. So for example, in degrees, we could talk about 180, okay, which we would see over here, 180 degrees, or negative 450, or 10,080. Another example would be 270 degrees, and that's the example we're going to be looking at down here for the next example. So we can go ahead and write 270 down here. All right. Other examples of quadrantal angles would be something like negative 90 degrees or negative 180 degrees, anything that's a multiple of 80. And we can also write quadrantal angles in radians as well. So 3 pi over 2 is an example of a multiple of 90. Negative 8 pi, that's an example of a multiple of 180. So anything that's going to be a quadrantal angle is either going to end with a pi or a pi over 2. So that's the one thing we got to watch out for these quadrantal angles. So if I were going to write one down here, I could say, well, pi over 2, that's a quadrantal angle. Or I could say 5 pi. As long as it ends with an over 1 or an over 2, it's going to be a quadrantal angle. Another example would be 17 pi over 2. Okay, anything like that. Those would be multiples of 90 degrees. For example 2, since theta ends at 270 degrees, we're going to start on the x-axis, rotate 270, and then we see here's the situation where we end up on an axis. So here's our angle theta, And if I try and draw a triangle back to the x-axis, I'm using this red line here, you'll see that it just doesn't really create a triangle, it just creates a straight line. So whenever we're doing this, it says use the unit circle. That's the key here, the unit circle, which means that we're going to be dealing with a radius of 1. So right here we can say, okay, well, here's our value again, that's r equals 1. So if we think about it, that means the y value in this case is going to be -1. Why is it negative? It's because we're going in a negative y direction down 1 unit from the origin at 0, 0. All right, the x value in this case happens to be 0. And that's because it doesn't go anywhere on the x-axis, it's going straight down. So whenever we're in this situation, we can evaluate the 6 trigonometric functions by saying, well, y is going to be -1 over r, which is 1. So this really just simplifies to -1. All right. Cosine is going to be 0 over 1, which 0 over 1 just becomes 0. And then the last one, tangent, is going to be -1 over 0. And anything divided by 0 is going to be undefined. So there is actually no trig value for tangent there. Then to get our reciprocal trig functions, we would just say 1 over -1. So cosecant also going to be -1. Secant is going to be 1 over 0, which is undefined. And then the last one, cotangent, is going to be 0 over -1, which is just 0. Okay, now I have 4 practice problems for you guys to evaluate the 6 trigonometric functions. So start by writing down your 6 functions and give this a try. You want to create triangles for these ones, problems 1 and 2. When we get down to problems 3 and 4, you're going to see problem 3 is going to be another triangle problem. Problem 4 is going to say use the unit circle. And you're going to evaluate theta equals 180 degrees. So it's going to be one of those weird ones that ends on the axes. Okay, so try those 4 practice problems out. Pause the video now and we'll go over answers in a minute when you think you're done. I hope you've had time to work on all the problems. Let's go ahead and start on problem 1 here. We'll take a look at this one together. So first thing we want to do is go ahead and create that hypotenuse of the triangle. Or I'm sorry, we're going to draw the triangle back to the x-axis. And then we can calculate the hypotenuse. Since we know the legs are 3 and -3, we can go ahead and add those things together and square root them. We're going to find the radius of this triangle. So we end up getting 9 plus 9 equals square root r. So the square root of 18 equals r. We want to keep that in an exact answer. Square root of 18 can actually be simplified. That can be broken down to like square root 9 times square root 2. And square root of 9 is just 3. So the radius is going to be 3 square root 2. That's what we'll work with here. Since we know the y value is -3 because we're going 3 units down, the x value is going to be +3 because we're going over 3 units. Now when we evaluate the 6 trig functions, we're going to get -3 over 3 root 2. There's just one problem with that. We don't want a radical in the denominator of our fraction. So what we need to do is we need to multiply both the numerator and denominator by that radical, root 2 over 2. So we really end up with something over here that's going to look like -3 root 2 over 3 times root 4, which simplifies to -3 root 2 over 2 times 3. And then the -3 and the 3 will divide out. So we're really left with -root 2 over 2. All that work, and that's what we're going to end up with over here. So I'm going to erase that stuff over here. I'm just going to put my answer down. It comes out to -root 2 over 2. Similarly, if we did the same thing with the cosine, we're going to end up with a +root 2 over 2. If we did the tangent, we're going to do negative 3 divided by 3. That just simplifies to negative 1. Our other values on the other side, cotangent will also be negative 1. Cosecant is going to be negative square root 2 when it simplifies all the way down. And secant is going to be positive root 2 when it simplifies all the way down. Now I'm going to zoom out. You guys can take a look at your other problems here. Remember to come to office hours if you have questions. But here's what problems 1, 2, 3, and 4 look like from those examples. All right, we're going to get started on reference angles and second here, but take a minute to look at those answers, or look over those answers. The next thing we are going to discuss here is reference angles. And this is the reference angle for theta is always an acute angle. It's going to be called theta prime, formed by the terminal side and the x-axis. Very important that it's always the x-axis, never the y-axis. And we can see examples of that here in quadrants 2, 3, and 4. And right here we see a little vocabulary as well. I'm going to highlight it in green. It says 90 degrees is less than theta is less than 360. Or in radians, pi over 2 radians is less than theta is less than 2 pi. And that's just always referring to what quadrant we're in. So for example, quadrant 2 is going to be the same thing as 90 degrees is less than theta is less than 180 degrees. Whenever you see that, we're talking about, hey, specifically, when we're rotating between 90 and 180 degrees, we're going to be in quadrant 2. Likewise, in quadrant 3, that's going to be when we are between 180 degrees is less than theta is less than 270 degrees. And then the last one, quadrant 4, is if we rotated between 270 degrees is less than theta is less than 360 degrees. That's why this whole thing up here says from 90 to 360. That's where those values come from there. Whenever we're referring to reference angle specifically, we're talking about, again, the angle is formed from the terminal side, which is the blue line, and that goes straight down to the x-axis, or in quadrant 3, it's going up to the x-axis. Terminal side to the x-axis. Quadrant 4, going back up to the x-axis. So if we're looking for reference angle theta for each angle, we start by drawing the angle of rotation. We'll say, okay, we're going to start in standard position here. We're going to rotate 5 pi over 3. So 5 pi over 3 is going to end somewhere over here. I know 6 pi over 3 is the same as 2 pi radians. So that's going to be one full rotation. So our terminal side is going to end somewhere over here. If I'm looking for the reference angle theta prime here is going to be thinking about, we had 6 pi over 3. So we are just 1 pi over 3 away from that. Or we're subtracting 5 pi over 3. We're going to be 1 pi over 3 away from that. That's how we would get our theta prime here. Just 1 pi over 3. Thinking about it in fractions, 6 pi over 3 minus 5 pi over 3, or 6/3 minus 5/3 if we don't want to deal with that pi. Likewise, if we do it in degrees, we have negative 130 degrees. So we're going to rotate down instead of up. I know we're going to go past 90, but not quite 280. And this is going to be our theta equals negative 130 degrees. Reference angles are always going to be positive. And in this case, we're thinking, well, we have to rotate 280 degrees. So 180 minus 130, we're only how many degrees away from that full rotation of 180? We're 50 degrees away. So theta prime in this case is 50 degrees. Degrees might be easier for you to work with than radians, but we're going to need to know how to do this in both. So it's important to practice both. Now, the last thing we're talking about today is evaluating trigonometric functions. And we have 3 steps here that we say. First, we want to be able to find the reference angle. That's step 1. Okay, whenever we're looking for the reference angle, it also determines which quadrant we're in. And then we're going to evaluate the trigonometric function for that angle, theta prime. Okay, and the last part says determine the sine of the trig function value from the quadrant in which it lies. And what I mean by that is we want to think about quadrant 1, quadrant 2, quadrant 3, quadrant 4. Is the sine going to be positive or negative in that quadrant? And we can tell because remember the sine is always going to be the y values. So the y values, for example, those are going to be positive in quadrant 1 because we're in positive y's here. That's going to be positive in quadrant 2. In quadrant 3, when we go below the x-axis, the y values are negative. And that means they'll be negative for quadrant 4 as well. Cosecant's going to follow the exact same thing because it's just reciprocals of whatever sine is. Because it's always going to be the y value over the radius, and the radius is always positive. So it's the y value that determines the sine. Cosine is going to be positive in quadrant 1 because we're dealing with the positive x-axis here. It's also going to be positive in quadrant 4. Same with secant as well. And cosine is going to be negative in quadrant 2 and negative in quadrant 3. And then the last one, we've got tangent y over x. Positive y over positive x is going to give us a positive tangent in quadrant 1. That means cotangent will also be positive. In quadrant 2, we notice that the y is positive, but the x is negative. Positive divided by negative is going to give us a negative tangent value. In quadrant 3, we have a negative divided by a negative because we have a negative y and a negative x. That's going to give us a positive tangent value. And in quadrant 4, it's going to be a negative divided by positive. That's going to give us a negative tangent value. So the tangent is kind of the trickiest one to determine there, but we should still be able to determine the sines. Let's go ahead and look at example 4, evaluating the function without using a calculator. So with example A, the first thing we want to do is find the reference angle theta. That's what step 1 tells us to do above in the steps. So we're going to rotate negative 240 degrees. Well, I know that's more than 180, less than 270, so we're going to end up over here somewhere. There's our theta at negative 240 degrees. We're looking for our reference angle now, theta prime. We have to say, how far is it going to be past 180? So if I said 240 degrees, doesn't matter whether it's positive or negative. I'm just going to say let's minus 180 from it. We're going to be 60 degrees back to that angle. Sorry, theta prime equals 60 degrees. That's the first step. Now we want to think about, we're in quadrant 2, so we're going to draw this 60 degree angle. Whenever I'm evaluating without a calculator, I'm typically going to end up with a special right triangle, either a 30, 60, 90 or a 45, 45, 90. In this case, I'm going to end up with looks like a 30, 60, 90 triangle there. I'm just going to redraw the triangle over here for my own reference. Be a little easier to use. I know this is a 60 degree angle. That's my theta prime. That means there's going to be a 30 degree angle up here. Whenever I'm evaluating without a calculator, I'm going to assume the radius is 1. And now I need to use those trig functions. That means the short side, the short leg is going to be opposite the smallest angle. This is going to be 1/2. And then the long leg is going to be that 1/2 times square root of 3. So this becomes square root of 3 over 2. Because I'm in quadrant 2, the y value is positive. So that root 3 over 2 is going to be positive. But the x value is going to be negative 1/2. So very important that I note negative 1/2 there. And if I do that right now, that's really taking care of step 3, where it's saying determine the sine of the trigonometric function. Because we know the y value is going to be positive, the r value is always positive, and in this situation, the x value is going to be negative. Now I'm evaluating the trig function, where it says tangent. So tangent, in this case, of negative 240 degrees, or we can use the reference angle of 60 degrees, it doesn't really matter. It's going to be root 3 over 2 divided by negative 1/2. And whenever you're dividing one fraction by another fraction, you're really multiplying by the reciprocal of the second fraction, which is negative 2 over 1. And we see the 2's divide out here, and we're going to be left with root 3 over 1. But it's negative root 3 over 1. So in this case, tangent of negative 240 degrees is negative square root 3. That's how we would do example A. For example B, it's a little trickier because we're dealing with a cosecant of 17 pi over 6. So first thing I see cosecant, I'm going to think that corresponds to sine. That's the reciprocal of sine of 17 pi over 6. So that's what we want to work on here. So first we're just going to find 17 pi over 6 on our circle. We're going to go to positive direction. Okay, this is kind of a weird one because I know 12 pi over 6 is the same as 2 pi. 18 pi over 6 is the same as 3 pi. So we're not quite going to get to 18 pi over 6. We're going to end up over here somewhere. That's going to be our 17 pi over 6. Whoops, 17 pi over 6. And then we ask ourselves, how far are we from the reference angle? Well, we need to go 18 pi over 6 to get to that axis. We've gone 17 pi over 6, so theta prime is pi over 6. That's how we find that value there. So that's the first step. We can draw another right triangle, and we've got pi over 6. It's important that we memorize the pi over 6 value, which is equivalent to 30 degrees. Pi over 4 is equivalent to 45 degrees, and pi over 3 is equivalent to 60 degrees, like we just saw up above on a previous example for part A. Up here, let me highlight it real quick. Up here, we saw that pi over 3, that's a 60-degree angle. So that's how we can identify these special right triangles here. Now with this 30-degree angle being formed, we can identify opposite the 30-degree angle. Our y value is going to be 1/2. And that's because our radius is always 1. And that means our x value here is going to be -√3 over 2. And we talked about cosecant of 17 pi over 6. So we're really going to evaluate sine right now, which is going to be 1/2 over 1, which is nice because it's just going to be 1/2. So that's what we're doing for this sine of 17 pi over 6. Now we have sine is 1/2, so cosecant of 17 pi over 6 is the reciprocal of 1/2, which is 2. That's how we'd find the cosecant of this particular value. Okay, so the last thing for you guys today, there's just a few more examples here. Problems 5 through 8. It's a sketch the angle, then find its reference angle. And there's even one that has evaluate, so those ones should be pretty straightforward for you, 5 through 8. Sketch the angle, find its reference angle. Problem 9, evaluate cosine of -210 degrees without using a calculator. So I'm going to go ahead and put these answers up, but it's up to you guys to solve them. If you have any questions, please hit us up during office hours this week. Thank you. All right, here are all the answers for the last 5 problems. Again, just make sure that you check your answers, and good luck on the assignment.